All right, so as we go into examples on area of a circle right now, try not to feel overwhelmed. Draw pictures and break things down into the formulas so you know what information you need. Okay, so keep that in mind as we're doing these. A sprinkler rotates in a circular pattern and sprays water over a distance of 12 feet. What is the area of the region covered by the sprinkler? Now, it says draw a diagram to assist you. Okay, so I get that it can kind of be confusing, so draw a picture. Okay, and basically our sprinkler is spraying right here, and the water shoots out over 12 feet. So what does the 12 represent? Excuse me. It's our radius. Okay, think of the sprinkler. It's coming here in the center. It's going all the way around, and it's shooting it out 12 feet. So the 12 is our radius. Okay, now what is this asking us? It's asking us for the area. So I'm going to write down my area formula. Area equals pi times the radius squared. So if you write down what your formula is, then you know what you need. I need a radius. Okay. Oh, I have a radius. So my area equals pi times 12. I substitute 12 in for r to the second power. Now, this again means 12 times 12. So my area equals pi times 144. Now, remember, we tend to write the 144 first. This right here in square feet. Area is always measured in square feet or square inches or square whatever. This is our exact answer. Okay, so if you have any problems that ask you for exact, you just leave the pi in it. But we can also type it into a calculator and go 144 times pi equals, and we get 452.389. Okay, now this says nearest square foot, so that's the 2 here. Okay, I look at the 3 behind it. Does the 3 tell us to stay at a 2 or move up to a 3? Stay at a 2. Okay, so we have our exact answer and our approximate answer over here. Okay, draw a picture, write down the formula. Let's look at another example. Suzanne is making a circular table out of a square piece of wood. The radius of the circle she is cutting is 3 feet. Draw a picture. Okay, so there's my square piece of wood, and we're making a circle out of it. I knew that wasn't going to be quite so easy, right? No, not too bad. Okay, so we have the circle here out of the square piece of wood. It tells us that the radius of the circle is 3 feet. How much waste will she have? The waste is going to be these corners. So if you just step back and think about this for a second, if I can find the area of the square and I can find the area of the circle, I would subtract them, and that will tell me what my waste is. So how do we get there, right? Well, we know the radius is 3. The radius is the distance from the center to the outside. So that also means this is 3. So what is this whole length here? 6. And since this is a square, guess what? This is 6. So if I want to find the area of the square, I can just go length times width, which is 6 times 6, which is 36. If I want to find the area of the circle, I use my formula, pi times radius squared. Remember, my radius is 3. So this is pi times 3 to the second power. 3 to the second power is 9, so that's 9 pi. Now I'm going to stop at my exact answer there. You can absolutely approximate it. I'm not going to be concerned, but I'm going to stop there. Because remember, to want the waste, I got to take the area of the whole thing, the rectangle, or the square, not rectangle, and I got to subtract the area of the circle, 9 pi. Okay? So 9 times pi is about 28.27, we'll say. Okay? And so if I go 36 minus that, It's about 7.73. Okay. To the nearest square foot, okay. That's 7. I'm going to look at the 7 behind it. Does that tell me to leave it at 7 or round it to 8? It tells me to round it to 8. So we're going to say the waist will be about 8 square feet. Now I know that seems like a lot, but draw a picture and use your formulas, and it'll help you get to the answer. Okay? And I want to do some of these example problems to help you out. Okay, so just a couple more, I think. Yep. All right. The circle has a radius of 2 centimeters. Find the exact area. All right, no problem. I'm going to draw a picture, and it tells me that my radius is 2 centimeters. I want the exact area. Area, write my formula, pi times the radius squared. My radius is 2, so I get pi times 2 squared. Well, 2 to the second power is 4, so I have 4 pi. And again, I'm just switching the order because we tend to write the number first and then the pi symbol. Okay? Centimeters, so it's square centimeters. That is the exact answer. Now, if we approximate it, now it says using 4, we could go 4 times 3.14. I'm going to be honest, I tend to use the pi button. I would tend to go 4 times pi and get about 12.566, right? We'll say 12.57. Okay, so we have exact and approximate. And then where does this come? Find the circumference. How do we do that? Write down the formula. Circumference equals pi times the diameter. Do I know the diameter here? No. Okay, what do I know? Okay, well, I know the radius up here is 2. Okay, so what I can do is how do I make that jump from radius to diameter? Remember, we multiply by 2. So I know our diameter is 4. Okay, so I can plug that in here. So even though it seems like we don't have enough information, use what you know. Write down your formulas and try to figure it out. Okay, so basically this is 4 times pi, and we get about 9.87, I'll say. Now, circumference is the distance around the outside. It's our perimeter. So that one is not in square measures. That is just in centimeters. All right, one more. Joan determined the area of the circle below is 400 times pi square centimeters. Melinda says, nope, you are wrong. It's 100 square centimeters. Who's correct? Okay, in both of these, we're dealing with area. Area equals pi times the radius squared. Have you seen how many times I've written down the formula? Write down the formula. Pi times our radius. Okay, what's our radius here? Okay, well, since they draw the line all the way across, 20 is our diameter. Now notice when I was drawing it before, I always put a dot in the center. I would just draw the outside. That's kind of how we symbolize that it's radius. Since they went the line all the way across, even though the 20 is kind of written up the top here, that's diameter. So how do I figure out the radius? Well, if the distance all the way across is 20, what's the distance from the center to the outside? Just 10, right? So we can plug a 10 in here, and we go 10 to the second power. 10 to the second power is 100. Oh, so look it. We get 100 pi. Have a feeling that Joan here, she used 20, right? If you would have went 20 squared, you get 400. So the correct answer is 100 times pi. So Melinda's right. Draw pictures, write your formulas down, okay? Use what you know and the relationships between diameter and radius to be able to solve for both area and circumference.